Okay, so far we have modeled some very rudimentary rectangles. Started in 2D, we brought it up into 3D. Not very interesting. So let's get into something a little bit more unique. So we can create irregular polygons and extrude those as well. Very similar to what we have been doing. It's pretty much the same steps. So we're going to start in the corner of this pad. We're going to change this to S. Go here to beam. Yes, bracket. Let's use bracket. Let's create a steel bracket. We're going to create a little piece of channel that this transformer is going to live on because it has feet on top of being on top of a slab. You would create an appropriately sized channel. So let's go 4 inches by 3/8. 5, which is actually some pretty thick channel. But by using orthogonal, we are automatically locked in. So we're going to minus 375. Nope, I missed a period. 0.375. There we go. That's going to be interesting. So, go up 4 minus parentheses 3, 5. 5 times 2. Close parentheses. Hooray. Ta-da! There. Very rudimentary C channel. Which we can now use solid by extrusion and extrude out our transformer feet. It's kind of hard to see it, so let's go ahead and change illustration, ignore lighting. Haha, there we go. And you can see it just a tad better. So we have equipment pad, steel brackets. Let's go ahead and we know we need to mirror that to the other side, so we'll select it. And here under our manipulate, use a mirror. Prefer to use a line typically. I leave it set to line because why I have the extra command of flipping between horizontal and vertical. Ah, I missed something. Make a copy, because I didn't just want to move it. I want to make another one. There we go. So now we have our bracket feet. Our last step, we need to set our actual transformer. And you'll notice something. I was off. So we have the pad size and then we have the transformer size. Let's go ahead and move our brackets into place to our transformer outline. So, tentative, using enter to lock our axis so we aren't moving things around in 3 dimensions, we're just using 2 dimensions. Now you'll notice there's this one little handle here. This allows us to alter our extrusion length. You'll notice it's still picking up that Z distance. So we want to hit enter to make sure we are only editing it in that one dimension. There. Now, we have 2 little feet. I'm doing what we did earlier. Hold Alt, left click to change our level. And let's create our transformer. Enter. Remove ortho temporarily. Let's say this guy is 2 feet tall. Hooray! There is our transformer. And we've made something, yeah, a little bit more detailed. Now, there's 2 things you could do. You could go ahead and combine these into a single model using the Unite Solids command. In this case, we want to leave them as a group because they're separate elements. We want to keep them separate. So we can go ahead, using Control, you can go ahead and use U. And left click. Oh, come on. That's, oh, that is not correct. Okay. So Control U. No. Gonna need to edit this one out. Select Control G. There we go. Control G unites the group. If you want to separate it back out, then it's Control U. So there you go. So let's go ahead and make this a group. So select everything, Control G. And now it's a group. It can also be found. It's up here somewhere. Let's see, where is it? Trying to remember. Oh, where did it go? It's gonna bug me. Anyway, it doesn't really matter. Control U, Control G creates your groups. This is extremely useful when we get into compound cells, and we will revisit it then. So there you go. There's creating our rudimentary rectangles. Creating your other solids is pretty much identical. So let's say for whatever reason we needed to create a cylinder. Start with your cylinder. So if we want to create it at the center of this motor we kind of drew in 2D initially. Come out, you can lock your axes. There's our rough shape. See, this is, I was talking earlier about your UCS not letting you go in the direction you want to go. Select your view, hit V to rotate your UCS, and there we go. We can now make our 10-foot tall cylinder. Each of these shapes can be used for various reasons. They all work very similarly in premise to our slab solid. Your pyramids and the rest of these take a little bit more finesse to get to work right, but we don't typically use these shapes unless you're doing some very detailed modeling of rather unique equipment. The next line down that has our extrude by solid, you can do a revolve. If you're doing very detailed models, we have some in our compound cell libraries, which we will get more detail in, that use that revolve command. So if we place this guy temporarily, see the use of that revolved pattern symbol or creation type that was used to create the isolators on this. We'll also use extrude along path. We will get into that when we do duct bank modeling. Also use that for conduit modeling, which we will get into at the same time. We don't typically model in surfaces, so unless you're importing it from, say, Autodesk products, you won't normally use that tool. You could also do a linear solid. This is similar to what we were doing earlier. So you can set and create various linear solids in the process. All right, that wraps it up for this video. Next, we will get into modeling duct banks and conduits.